Welcome, public inventors. This video is your invitation to a unique, free, completely online event. Perhaps you've heard of a hackathon, a sort of programming competition. On the weekend of November 30th through December 2nd, 2018, Public Invention is hosting a completely free, cooperative, all virtual online mathathon. We call it a mathathon because it may involve computers, but is fundamentally about solving some open problems in geometry. When we say open problems, we don't necessarily mean hard problems. We've arranged a variety of problems with different difficulties, ranging from bright high school student difficulty problems to things that would probably be publishable if they were solved. To prepare for the Mathathon, David Jeschke and I wrote this simple web page that lets anyone experiment with the easiest class of problems that we intend to address in the Mathathon, and that is regular equilateral triangle put together in chains. The entire Mathathon, from a mathematical point of view, is about what we call simplex chains. But an easier version of that is just to think of equilateral triangles in two dimensions. So in this page, we've written a web page that allows you to enter a little snippet of JavaScript that defines how one triangle should be added to the next. And so the basic idea is, if you're dealing with completely regular triangles, you can build a chain by simply deciding whether you want to go left or right from the first triangle. And so here we have a little bit of JavaScript code which takes a natural number and returns either the string L for left, the string R for right, or S for stop. And this simply turns to the left 6 times. And so if we hit go here, we're going to see it draw a very small hexagon. There we have at the bottom of the screen a hexagon. By making this code a little more interesting, we can define a beam, and this is code which is returning left if the input is even and right if the input is odd, and that defines a beam going off in a particular direction. We can also define a triangle if we make it a little more complicated, as you can see here. And we can define a hexagon, which is more fun, and a shape called a trefoil. Now, you may think, well, these are trivial problems which are not interesting, but in fact, this whole idea of putting together equilateral triangles is actually very practical mathematics, because it's motivated by structural engineering and robotics, which uses the inherently rigid nature of triangles to build interesting shapes. Now, it's of course the case that we can also perform this in 3 dimensions where we have tetrahedra. This is an example of a structure made completely out of tetrahedra called the tetrahelix. Dealing with the mathematics in 3D of tetrahelixes or tetrahedra chain is significantly more difficult. This would be more for college students and graduate students and professional mathematicians. But as I said, in the Mathathon, we've arranged a variety of problems. In fact, we've written out a number of problems, as you can see here in this PDF, describing the rules of the Mathathon, the general motivation, and giving some sample problems. We call these open problems, not necessarily because they are unknown solutions which will make you famous if you solve them, but because they're serious problems which we hope are well defined. Here we've defined some easy and some medium ones, medium difficulty ones, but because they are truly unknown to us. Now, by relaxing regularity and moving into 3 dimensions, we can make the problems much, much harder. So in fact, we've defined a large number of interesting, I hope they're interesting, questions about simplex chains for the Mathathon. So we think we're doing something a little unique here. I don't know if there's ever been a Mathathon like this before. Our idea is to make it cooperative, to address open problems, and to have all submissions be released under the Creative Commons Attribute Share Alike license. So this is free of charge, and it's also a free libre, or free as in speech, Mathathon, where everything that we produce will be freely reusable with attribution by others. So hopefully this is a unique event. At the moment, not very many people are signed up. We're committed to running the Mathathon in any case, but we would like your help in promoting it to the kind of person who might be willing to spend a significant portion of a weekend working on a variety of open problems around the geometry of how to stick together tetrahedra, or how to modify tetrahedra to make particular shapes, or how to modify simple triangles, which is a little bit easier. So one of the, as an example problem, which I have not solved, so it remains open to me, although I haven't spent very much time on it, is to ask the question, could you use the web page, which we've created here, to create a snippet of code which in fact fills the entire plane? And I'll just leave that as an exercise to the reader, which hopefully you will enjoy. Thanks, and please, if you're interested and you're willing to do it, forward this to someone who might sign up for the completely free, completely online, all virtual cooperative Mathathon. Thank you.